Today we're going to look at two formulas here, and these are called the simple interest formulas. I is the interest. So if the interest rate, let's say, equals 2.5%, then one of the things that you're going to have to do to prep the for the formula here, this interest equals PRT, is you're going to have to let I be the decimal version of this number. So move the decimal point 2 places to the left. So this percent and this interest rate are the same. So one of the things you're going to have to do in this section is to convert from percentages to decimals, decimals to percentages. Now the P in this formula stands for principal, and we will call it later on the present value. What's the value of the investment, or what's the value of the loan presently, right today? And this will be a dollar amount in all cases. And what we'll do is we'll round all money amounts to the nearest penny. So 2 places after the decimal point. Got the wrong one up here. This one up here should be the interest rate, R, in the formula. Now the big I is the interest. And this one also is money. The difference is this one up here is the interest rate, and this one down here is the amount of the interest. So it's a dollar amount. And this could be interest earned or interest paid. And that depends on whether you are the purchaser, or the borrower, or the loaner. Are you loaning the money or are you borrowing the money? But it is a dollar amount. And T equals time in years. So you may have to do conversions, like if they say, I'll do 2 examples. Let's do 13 weeks. So if we do 13 weeks, there are 52 weeks in a year. And so if you want the number of years, you take 13 weeks. And then since there are 52 weeks in 1 year, you can do some unit analysis, convert the weeks, and you get 13 over 52. Oh yeah, that's 1/4. That's 1/4 of a year. What's important here, if they tell you that this loan lasts 13 weeks, that the number that has to go into the formula is not 13, but rather it's 1/4, because in our formulas, the T is always coded in years. Keep that in mind. And those are it. The only other one that we have is in this other formula here, the A. And the A is the future value. It could be the amount of the loan, but it's also in dollars as well. Now, one other, I'm going to give you another example with this time. They could give you, let's say, 60 days. 60 days. Now you have to make an assumption about how many days are there in the year. And, because of leap year comes every 4 years, there's actually 365.25 days in a year. But it turns out that our estimates using these finance formulas, they're not significantly different if we use number of days in the year to equal 365 or 360. I think our author uses 360, or says assume that the number of days in the year, when you have a problem that deals with days, assume that the number of days in the year is 360. So we could do it in 2 different ways. We could take 60 days and then take 1 year over 360, and that's 1/6 of a year. Or we can take 60 days and divide by 365, and that's 60 over 365, and some version of that. So just to kind of show you that those numbers aren't too different. 60 divided by 360, there's the 1/6. And then 60 divided by 365. Okay, so to the nearest 100th, they're the same. And because of that, you're going to get very little rounding error if you use 360. So if you're working in my math lab and they say assume that the number of days in the year is 360, then just use that if you want to get the answers correct on the first time. Okay, that's it. That's all I have for the new formulas. But all of these applications are a little bit different, and it helps to know the context a little bit. So we'll work through a few of them. And let's start off with some of the things that you're going to be, some kind of basic skills you're going to need to do these problems. The first set is to convert the given interest rate. Okay. So remember that the given interest rate is R, and this has to be a decimal. So if they do give you a percent, you'll have to convert it to a decimal. If they give you the decimal, then you don't need to worry about it. All right. But here they want you to convert percentages to decimals and decimals to percentages. So to change a percent to a decimal, move the decimal point 2 places to the right, and move it 2 places to the left, and then take away the percent symbol. If you have a decimal, like this one here, you move the decimal point 2 places the other way to the right, and then you would get 0.84%. All right, so why don't you go do the rest of those? Let me just show you how these rates work. And in particular, we don't always use just a decimal and a percent. Sometimes, like for the COVID deaths, we use deaths per 100,000 or deaths per million. So here's what this would look like right now for the United States of America. Currently in deaths, and I'm just going to round this off, I think we have about 202,000 deaths caused by, COVID was one of the causes. Many times, as you know, there's these underlying conditions, and someone might have congestive heart failure, they get COVID and they die, and they're classified as a COVID death, even though there are other things that contributed to it. The population of the United States, let's say it's 330 million. That's a good estimate. So if you wanted to do a rate here, then we would say, just take those two numbers, divide them, and you get 6.12, looks like 12, times 10 to the negative 4th power. That's what that E negative 4 means. All right. If you actually wrote the decimal, because of the negative 4, you'd have to move the decimal point 4 places to the left. So it would look like this. I'm just going to round it that way. So that's the rate. And then if we want to do percent, we move the decimal point 2 places to the right. It's like when we say percent, we really mean per 100. Cent, like centurion and century, all involve 100. 1 cent is 1/100th of a dollar. That cent prefix means 100. So when we do percentages, we're really meaning per 100. So there's this many deaths per 100 people in the population. But that's such a small percentage, we could say this. If you move the decimal point 1 place to the right, then this would be the number of deaths per 1,000. If you move the decimal point another place, you have per 10,000. And if you move the decimal point another place, you get 61.2 per 1,000. We use percent or per 100 a lot because we're used to working with it. But when the rates are really, really small, like the COVID death rate, then we tend to say, instead of per 100%, we tend to say per 100,000 or per million. Now, the easiest way is just to take the rate and multiply by 100,000. If you take that number and multiply by 100,000, you'll get this number. And then you could say 61.2 per 100,000. And this is kind of the only real valid way that you should compare cities or counties or states or even countries. If you want to compare how well they're doing, all you have to do is take the number of deaths in that country divided by the population of that country, the number of deaths in that county divided by the population of that county. And then you would be able to compare apples to oranges. Okay, 8.5%, 0.0435. Notice they're giving you a lot of percentages that that are small numbers. Well, because when we're investing money, our rates are fairly small numbers. So that's what you should have gotten for all of those. Any questions on those? I'd like to work them out in some detail if you have questions, but if not, I just want to move on. It's just a matter of moving the decimal point one place or the other. All right, here's a problem. This next, seeing no questions, this next group of exercises deal with converting to time. And notice here's that blurb that says, assume a 360-day calendar year. And the only one it really affects are the ones that say days. Okay, so what does T equal? 180 days is a unit of time, but when we plug that into our formula, we have to have time in years. So we're going to take the 180 days, multiply by 1 in the form of 1 year equals 360 days. Delete the days unit, so the only unit remaining is the years unit. And then 180 divided by 360, that's exactly 1/2. So 180 days is about a half of a year. That's what they're saying here. And the number that we would type in for T into our formulas would be the 1/2. Okay, why don't you go ahead and do those others? Okay, so 18 is 3/4 of a year. You can see the unit analysis there where we're canceling out the units, changing months to years. In a similar way, 19 would be 4 out of 12, right? So 1/3 of a year. And 90 days would be 1/4 of a year. Now, not all problems you're going to have to do this because there'll be many problems where they say, well, how much interest is in the account after 3 years? Well, if they tell you that you're in that problem that you're dealing with 3 years, then you just say, oh, T is 3, and there's no conversion that you need to do. Okay, so kind of these are the preliminaries. Now let's kind of go into some problems that use these two formulas. So these are the two formulas that you're going to use in this section 3.1. All right, so let's take a look at these here. It says use formula 1. Now formula 1 was the, okay, well I don't have it on here, but this is formula 1. It's the interest formula, I equals PRT. So I'll put that here, PRT. So you start off with the formula, and you notice that there are 4 different variables in that formula, I, P, R, and T. And the way these problems typically work is they're going to give you 3 of those 4 and then ask you to find the missing 4th. So it's nice when they label them like this. So we're going to put in 300 for P. The interest rate is 7%. But it must go in as a decimal number into our formula. So 0.07, and then T is equal to 2, and P is equal to 300, and we're trying to find I. So that's it. Just make sure that your answer is appropriate. That means it has a unit attached to it. If it's a dollar amount, pennies and cents. So 300 times 0.07 times 2, and that equals 42. So $42 in interest. So if you were loaning someone $300 and they kept that money for 2 years, that at the end of the 2 years, you can expect your full $300 back, and you can also expect interest in the amount of $42. All right, let me show you what you have to do if you have a problem like number 28. Again, the stem of the problem says to use this formula. Interest equals principal times rate times time. Now in this one, they give you the interest amount. It's not the interest rate, it's the interest amount. So that's $15. There's no need to change that to some other format. The interest rate is 8%. We do convert that to a decimal. Okay, T, you know what quarters mean? Yeah, quarters are chunks of 3 years, or chunks of 3 months, 3/4. Think of that as 3/4 of a year. All right, there are 4 quarters in a year, so this would be 3/4. There are 4 quarters in a year, 3 of them would make up exactly 3/4 of the year. So in this case, you're earning interest of $15. What did you have to invest in order to, at 8% for 9 months, 3/4? in order to make that $15. All right, now this one involves a slightly different approach. You're going to put in the 15 for I, and the number we don't know is the P. However, we do know that the interest rate is 0.08. And now I have mixed representations of these numbers. I mean, I suppose it might make sense to just write 3/4 as 0.75, so you have all decimals there. All right, now this one involves some algebra. So you're going to have to solve some simple algebraic equations. And in this first section, they're only going to be linear equations. So just remember, whatever you do to one side, you have to do to the other. I'm going to divide both sides by 0.08 and 0.75, so that the 0.08s cancel and the 0.75s cancel. And so you get P equals, and then for the rest of this, just get your calculator out. 15 divided by 0.08, also divided by 0.75. And it turns out that it's 250. So we would attach the unit to it, circle it, say there's our answer. So if you invested or borrowed $250 for 9 months, 3/4 at 8% interest, you'd have to pay back $15, or you'd have to be paid $15, depending upon whether you're the borrower or the lender. All right, so solving some algebraic equations. Okay, so the next one takes into consideration the future value, which you're going to have and the way it works is something like this. The future value is equal to the principal plus the interest. So if you loan somebody, say $300, and you loan them that money for 2 years, let's say, after the 2 years is up, not only do you want your $300 back, but you also want the interest. So what you want back is the principal, the amount that you actually loaned, plus the interest. This simple formula comes back over and over again throughout this chapter. And if you can just remember that the future value is equal to the principal plus the interest, or a loan amount is equal to the principal plus the interest. It's just in this formula, see this P here? We have a formula for it. Or the I mean. The I, we have a formula for it, and it's right up here. The I is equal to PRT. So I'm going to change this I to what its formula equivalent is, PRT. Then I'm going to factor out the P, and I'll be left with 1 plus RT. And here's the second formula that they want you to use in this next section. But it takes into consideration not only the interest that you're going to be paying, but also the total amount you're going to be paying back, including principal and interest. So there's the formula they want you to use here. Okay, maybe 34 would be a good one here. Has a couple of interesting feature, a decimal in the percent. It also has 30 days. So I think what they're going to say here is they want you to use the 360 days. And maybe what we can do is do it both ways. One with 360, one with 365. Okay, so let's take a look at 34. We're looking for A, find A, and so we don't know A. We need to go find it. The principal is 3,000, and then we have 1 plus the interest rate. Be sure to move that decimal point 2 places. If you only move it once, then we're talking like a 45% interest rate. It's really nice. That goes in here, and then T. Now T is equal to 30 days, and so if you multiply it, or if you divide it by 360, what is that? 1/12. Or if you divide it by 365, I won't even reduce that one. So let's do it both ways, just so we can see that, you know, there really isn't a big difference in the future value, particularly after 30 days. All right, so let's start off with 30 over 360, and then we'll evaluate it. All right, so this one just requires that you type everything into your calculator. Just think about what's happening here, though. You're borrowing $3,000. So at the end of the 30 days, you have to pay back that $3,000. But you also have to pay a little bit of interest. And the interest is a small interest rate, 4.5, but you only have it there 1/12 of the year. So the interest that you earn in 30 days is not very significant. So you're going to have to pay back $3,000 plus some change. Not a whole lot, but the calculator will tell you what that is. And to really understand this unit on the math of finance, you should be able to look at the information given to in the problem and then estimate what the final answer is. In some applications, it's more difficult than others. All right, so we have plus 0.045, and then we have to multiply by 30 and then divide by 360. See what I mean? $3,000 plus some change. So using this one here, we would have 3011.25. Now let me type in that same thing and change the 360 to 365. See the difference? A difference of 15 cents. So there is some rounding error, but it's relatively insignificant. In fact, sometimes in my math lab, they'll say round to the nearest whole dollar. And if you do that, both answers would be 3011. So it wouldn't matter if you use 360 or 365. Okay, I'll pause here and let you work one out. And how about if you work out number 36? Come up with an answer for 36. Okay, so think about what a reasonable answer is here. After 9 months, 3/4, you're going to pay back this 6608. So what you must have borrowed 9 months prior is an amount that's a little bit less than 6608. So the number you're looking for is a number less than 6608. Take that information into you as you're punching numbers on the calculator, because if you get something larger than 6608, you know there had to be an error somewhere. Okay, very good. This is another one that requires an algebraic equation. So 6608 equals P times 1 plus 0.24 times, I'm going to again put the 0.75 in there as we did before. All right, I'm going to evaluate all of this just to get the number. And then the algebra step would be where we would try to isolate the P to find the present value. And to do that, we'd have to divide by that number attached to the P. And you are correct. P equals 5,600. Now, if you think about it, this is what those payday loans are, right? They charge you this unbelievable high interest rate of 24%. And notice in 9 months there, it went from 5,600 to more than 6,600. That means in 9 months, $1,000 is what it costs just for interest. Should never get one of those loans. That's why you should never carry a balance on your credit cards, because the smallest ones, the lowest interest in those credit cards is 12%, 15%, but they can go as high as 30%. So you never want to carry a balance on your credit card because you're just paying an unusually large amount, huge amount. $1,000, what a scam, right? Go to a payday lender, say, hey, I get my paycheck and I get some money coming in 9 months. Can you give me a loan for 5,600? Sure, but after those 9 months, you got to pay me 6,600, 1,000 more. Like the business model. Okay, let's go into some applications. And instead of just taking the loans and so on, I'm going to try to maybe go through a couple of problems that you might not be familiar with. So we'll start with number 64. A T-bill is a treasury bill. These are great investments because they're guaranteed by the U.S. federal government, by all the earning power of the U.S. federal government. And the U.S. federal government has never, ever, in its existence, ever defaulted on a loan. Every time that people borrow money, and that's what these treasury bills are, people buy them, and then the government agrees to pay them back after, 1 year, 2 years, 10 years. There's a 10-year treasury, a 30-year treasury, and even smaller periods than that, a 1-year treasury. And the interest rates change on all of those. If you take those out for a longer period of time, the interest rate will be different as if you took it out, say, within for a year only. But the double E savings bonds, those are the ones that mature after about 7 years. And that's what this is. But you have this little piece of paper, And, you know, it has, I don't know, some president here, some portrait. Looks like a ghost. But on the face, it has a number. I can remember when I graduated from high school, they had this on here, and someone gave me $100 treasury bond. I said, oh, that's great. Thank you. And these are the double E ones. And they say double E right on them. But after a period of time, they mature. And what this means, this 100 is called the face value because it's on the face of the bond. But the person who purchased this treasury bond purchased it for $50. When it matures, it will double and it'll be worth $100. But you have to wait until it matures before you can go cash it in. And if you take it out early, there's a penalty or something like that. So keep in mind that when you're doing these treasury bond amounts, when they mention the face amount or what it's going to be paid off in the future, that's the A value in our formula, A equals P times 1 plus RT. That's the future value. Okay, so there's a 26-week T-bill. That means you buy it today and it matures in a half a year, 26 weeks. With the maturity value, okay, so this is like the face value, maturity value. In the future, it matures and you get this increase in value. So in our formula, A equals P times 1 plus RT, the A is what the thing is going to be worth in the future. Earns an annual interest rate of 4.903, and that's a percent. So we're going to convert that to a decimal by moving the decimal point 2 places to the left and then taking away the percent symbol. And since it matures in 26 weeks, that's going to be the T value that we use to determine the number we put into the formula. 26 weeks is equal to 1/2 of a year. All right, so then we'll just work this one out. We have 1,000 equals P times 1 plus 0.04903 times 1/2. And because I'm going to plug everything into the calculator, I'm going to write the decimal version of 1/2, 0.5. I'm going to do this one in 2 steps, just like I did the previous problem. The first thing I'm going to do with the calculator is to evaluate what that number right there is. All right, so it looks like it's 1.024515. So the other thing that's going to make your life a lot easier is if you remember this simple thing, never round the intermediate results. So for example, look at the difference if I take that 1,000 and divide by 1.024515 compared to if I just took that 1,000 and divided by 1.02. So it's very similar, but in this case, rounding error of $4 is a little bit too much. So don't use the second version rounding that number, keep the entire number. Divide both sides by 1.024515, and then you get P equals that first number there, 976.07. All right, so you might say to yourself, gee, and as bonds don't seem like a very good idea, it looks like all I made was like $25 over a half a year. And that's right. And that's right. Very low interest rates, 4.9, and you didn't have it in there that long. Now, if you had it in there for 40 years and it was compounded, then you'd have a lot. But 976 grows to 1,000 after a year when it matures. Okay, I'm just kind of going through and trying one of each kinds of problems, so you kind of get a sense of all the different applications where simple interest can apply. But the formula that you can always use is that A equals P times 1 plus RT. In this section, we're going to get a whole new set of formulas in the next time. Okay. In this next grouping, 65 and 66, in this problem, when you have a credit card and you maintain a balance, then they require this minimum payment. And they determine the minimum payment based on two things. You either have to pay like a fixed amount, like $35, or you have to pay a certain percentage of the total amount that you owe. And so this problem says, how much are you going to have to pay? What's the minimum amount you're going to have to pay based on the criteria that they've established up here? So let's take a look. And I'll just do, 66, let's say. As I read the stem of the problem here, it says, assume that the minimum payment on a credit card is the greater of $20 or 2% of unpaid balance. So here's the strategy. It's the greater of. So if 20% of what you owe is under $20, then you have to pay $20. So let's say we calculated 20% of what you have borrowed, and it comes up to $13.45. What you would have to pay that month is the greater amount between $20 and that $13 and change. Well, $20 is larger than $13, so your minimum payment would be $20. So the least you would pay any month is $20, unless you, of course, didn't maintain a balance. A zero balance. Of course, you don't have to pay anything on a zero balance. Okay, so let's take the information here. And in our problem, it says that we currently owe on our credit card a balance of $936.24. Payment, $20 or 2% of $936.24. So we multiply 2% as a decimal, multiply them out. All right, so I'm going to just reason through this amount without calculating it. 2%, okay, 936 is close to 1,000. So if I took 2% of 1,000, I'd get 20. So it's going to be a little bit less than 20 here. And to get the exact amount, you can just use your calculator here. You could also say, well, 2% is 1/5 of 10%. 10% of 936 is 93, say 94. 1/5 of 94 is about 1/5 of 95, which is about $19. So we're probably looking at something around $19 here. And we'll round it. And so what's the minimum payment? The greater of those two. 18 is smaller than 20, so the payment is going to be $20 for this one. The way that this would work, this would be your purchase date, and what are we doing here? A T-bill. That's a treasury bill. And you purchase it here, and then presumably it's going to earn a little bit of interest over here. And then over here, this is when you sell that bond. Okay, so you sell the bond, and you might sell it back to the, wherever you bought it, a bank or federal government or whatever. And what's confusing about this problem, it says it sells for $996. So you think you're going to be putting $996 over here. But it turns out that what's confusing about this one is that the selling amount is $996, but that's what the bank sold it to you for. So the $996 is actually over here. This is the initial amount. In our formula, this is the value of P. And then when you, again, it's just trying to get familiar with some of the terminology that we're using. The mature date is over here, and you're going to sell this for $1,000. So you buy it, it earns a little bit, less than $4, and then you sell it. So in our formula, A equals P times 1 plus RT, they give you it's a 33-day bond, so the T value is 33 days. And remember, you have to put that in as a year value, so it's 33 over 360. If you use 365, there's going to be very little change. And what they ask you for there is that, what is the annual interest rate? So you've got A, you've got P, and you've got T, and the problem is to find R. I think it would work if you did it that way. You would first have to calculate, what the interest would be, and so you'd have to take those two numbers and subtract them, right? Right. So if you go from 3,000 up to 3,097.50, then the interest would be the 97.50. Yeah, and then you're looking for what there? You're looking for the interest rate. Yeah.
Right.
So R, and then you've got the T value and that one of 5/12. Yeah. So I think this is an easier equation, in fact, to solve than the one I did. But this should also give you 0.078.